All right, guys, this is the last question for review, although it has 4 parts. So I'm going to continue to move my screen as we talk about it. In each row of the table below, triangle JKL undergoes a transformation and is mapped onto triangle MNO. You are going to, for the first 3, sketch it out, and in the last one, take a look and compare those triangles. So if I were to get this question on a test, I'd take a look at what I have. Sketch triangle MNO for each of the transformations described, and then state whether it is always, sometimes, or never congruent to triangle JKL for this type of transformation. So you have a couple of different things that you're doing. Make sure that you provide support for your conclusion. And if it says it right in the test, you need to make sure that you get it done. So for this one, JKL, it says to rotate 180 degrees about the origin. If you take a look at what I've already done, I've gone ahead and rotated it for you so you can check to see if your triangles match. And then this is always going to be congruent. So this is an always statement. Why? Because rotations are rigid transformations. What do we know about a rigid transformation? It preserves size and shape of the original figure, meaning that these 2 triangles will always be congruent if all you've done is rotated it. And it doesn't matter. You can rotate it 90 degrees. You can rotate it 270 degrees. You could rotate it all 360 to map it back onto itself. It is the same triangle. In letter B, and just let me move my screen, this time you were asked to reflect across the x-axis. So again, if you take a look at my picture, I've taken that JKL, which is right here on my screen, and I've reflected across the x-axis. So you can check your MNO to see if that works. And again, is this always, sometimes, or never? It is always congruent because, again, reflections are rigid transformations. That's what this whole topic has been about. So because it's a rigid transformation, it preserves size and shape. In the next one, in letter C, or I guess this is letter B, translate 6 units down. So we take JKL, and again, I'll just show you my conclusion. I have just taken it from up here, and I've simply moved it 6 units down to create my NMO. And once I've done that, again, this is always going to be congruent because a translation is a rigid transformation, and rigid transformations preserve size and shape. So you've got that done. On the final picture, it asks you, is JKL and MNO congruent for this type of transformation? Well, you can clearly see that for this, since they've given us both triangles, I do need to go ahead and take a look at it. I have a coordinate plane. It's not one of those things where I'm letting my eyeballs fool me. I'm actually looking to see what has happened with that triangle. So if you take a look, I can see that this is not congruent. So this is never going to be congruent. Why? Because triangle MNO is a dilation of JKL. Therefore, dilations, not rigid transformations. If it is not a rigid transformation, they are not congruent. They may be proportional, and we're going to get into that in our next topic, but proportionality is not congruency. So dilations are not rigid transformations. They do not preserve size and shape. If you have completed this and you feel good about these questions, go ahead and look it over tonight, and you will be ready for tomorrow's test. Good job.